Compute the double integral over the region R of the function y dA, where a is the area element of the region R, and R is the region, the triangular region with vertices 0, 0, 0, 3, and 2, 2. So let's see if we can describe this region using some functions. Let's draw the region. One vertex is at 0, 0. Another vertex is at 0, 3. So this is the line x equals 0. And then we have here the point 2, 2. So 0, 0, 2, 2. Those 2 points lie on the line y equals x. And then the third line is here. The slope of this line, we have the y-intercept. So if we write y equals mx plus b, b is 3. So we just need to know m. The slope, if we go over 2, we go down 1, because this is the point 0, 3. Going over 2 will take us to 2, and then we have to go down 1. So the slope is negative 1/2. So the line is negative 1/2 x plus 3, y equals mx plus b. So we had to find the equation of a line through 2 points. One of them happened to be the y-intercept, so that was convenient. Okay, so we have the region. Now let's analyze the region, because we have a double integral. We could write it as an iterated integral, potentially in either order, dy dx or dx dy. When you write dy dx, then you're thinking of the region as being composed of horizontal slices, horizontal segments, and those fit nicely in this region because they'll just go from the bottom line to the top line, and we had equations for both of those. If we look at it the other way, so here's the region. If we look at it dx dy, then we're filling the region with horizontal slices. And this is a little bit inconvenient because the left half of the slice is nice. It's just at the y-axis, but the right half is at, here we have the line y equals, I'll write it as 3 minus x over 2, and here the right boundary is the line y equals x. So we have 2 different right boundaries, and so we would have to separate it into 2 different integrals. So it seems like the first choice is easier, so let's go with that. So we'll write the double integral in terms of, of y, we'll write it dA as dy dx. The x coordinates will go from 0 to 2, and the y coordinates will go for any x between 0 and 2. The y coordinate will go from the bottom line to the top line, which is from x to 3 minus x over 2. And now this is integrate. We get y squared over 2, and we have to plug in 3 minus x over 2 and x, and integrate dx. So this is integral 0 to 2. Let's take this 2 out here 1/2, because we have to square 3 minus x over 2, and then minus x squared. So we have to integrate this. So we have a little bit of algebra to do, but it's just an integral of a quadratic polynomial in one variable. So we have integral 0 to 2. Our integrand here is 9 minus 3x plus x squared over 4, and then minus x squared. So these two will combine, dx, these two will combine to give us 9 minus 3x minus 3/4 x squared. And now we can integrate. We have 1/2, our antiderivative is 9x minus 3x squared over 2 minus x cubed over 3. The 3's will cancel, and we'll get x cubed over 4. From 0 to 2, when we plug in 0, we get 0. So we just have to plug in 2, and we get 18. minus 12 over 2 is 6, minus 8 over 4 is 2, and this is 18 minus 6 minus 2 is 10, times a half is 5. The answer is 5.